Hello, welcome back at our Jörn YouTube channel. My name is Reinke and I'm very happy to see you again. Today I say hello from a meeting room which is next to our foyer, and here we have a displacement of some of our parts we have in production. But today I will talk about parts used for vibration control, for vibration reduction, and maybe if we have time I will show you some more nice parts as well. See you later. Okay, as I said, I want to talk about vibration control parts. These parts are mainly parts which have the main load in shear direction, because in shear direction rubber is pretty soft and is good to decouple. I will show you some examples. First example is this one. This is for lightweighted cabin of the truck. We have plastic outer tube, we have an aluminium inner part, and we have rubber segments here on both sides, and it's a double layer design, so with a metal sheet in the middle. This design is the same concept as it is with multi-layer slit bushes or dual bushes. I've talked about that already, and that gives pretty high stiffness in the longitudinal direction of driving and very soft in this direction. We have a similar part here. This is a triple layer part, but basically the concept is the same as the parts I showed you before. Here you can see some nicely designed bump stops in order to get a very smooth transition between the functional area of the stiffness curve to the final stop. And this part is pressed into around fitting room. But this fitting room is not part of our supply. This mount is a V-shaped mount, that's what we call it V-mount. Principle is the same. We have three layers, three rubber layers with two intermediate sheets for metal. The advantage of the V-shape is that due to the mass of the cabin or whatever is mounted, the middle part moves a little bit downwards, and by that we increase the compression to the rubber. And as further you move it down, as more progression you get in the stiffness curve. Again, we have a very smoothly designed bump area to get a nice transition between working area of the stiffness curve to the final stop. Same principle here. Again, little bit V-mounted, but not that much. Very specifically designed. You can see that. I will turn it around. You see it looks like a pyramid. So the first contact is similar to a point contact between the bump and the housing of the part, and that gives a very, very smooth characteristic and definitely no hard stop at the end. The outer shape looks a little bit oval, a little bit strange. How you can do that? It's very simple. By mounting it, it will be very much pressed in that direction. I can't do that with my force in my arms, I'm too weak. But then it's going to be round, and you have more space up and underneath the inner part. We have, in most installations, we have a metal tube inserted here in the hole, where the mount finally is fixed to the chassis, or to the cabin, wherever. And this tube can, of course, then a little bit rotate. Here we have another V-shaped mount, and that's a very interesting part as well. We have metal sheets, deep drawn metal sheets here on the outer area, and we have aluminium inner part. And of this mount we made many variants. We have different different parts in a tube or other names you can find, in order to adapt this to different applications. We have many variants of different rubber mixtures here in order to get different stiffness curves of this mount. It's also possible to get this with as a double layer mount, where you have higher stiffness in that direction compared to the direction stiffness in this direction. But how you can distinguish which part is which? Well, number one is we have a number here inserted, which is part of the tool, and the last two digits are changeable. So whenever you change the rubber mixture, you change the last part of the numbering system here. That's number one. And the other one is you get a colored marking on the outside in order to visually identify which shore hardness it is. We have a similar concept here, but just smaller. This one is also a pretty interesting part. We have 4 layers of rubbers on both sides of the inner part, because the customer wanted a very, very great spread between the stiffness, the longitudinal and vertical direction. Very thin rubber layers. The part looks like oval, but when it's pushed into the fitting room, it provides, number one, the compression, the pre-stress, pre-compression to the rubber in order to have always pressure in the material. And number one, it makes this one here becoming a round part, and then the free space where it can move in the longitudinal direction is increasing. We also have a flange here. We have a side pump for this part. Last cabin mount I want to show you is this one. This is something, it's a mount we call a conical mount because of its conical shape. That means we have a conical deep drawn outer metal and more or less tubular kind of inner part, and between that we have the rubber. You see here these two areas with no rubber. We can vary the size of these insertions in order to change the stiffness ratio from this direction to that direction, depending on the detailed specification of the customer. You can get those kind of conical mounts in basically 2 variants. One is with a tubular inner part, and another one is with a conical inner part. The conical inner part has an advantage in terms of stiffness increase by moving downwards, because then you apply more and more compression to the rubber, which is hardening the part. The tubular part is a little bit more simple technically wise, but it's significantly cheaper. You may wonder why the parts are displayed here like this. That's not the normal case. I just did that for the movie here. And just a brief explanation of what you see underneath. This has nothing to do with cabin mounts. These are links with 2 spherical joints or bush joints. And these kind of links are used in a bogie of a railway, for example. Just to give you a brief explanation of what you see here. Okay, well, we've cleaned up our displacement board here, and that means we're at the end of today's video. Thank you very much for watching. I hope you liked it. Please let us know. And if you liked it, please follow us here on YouTube. And of course, switch on again when we welcome you again at our YouTube channel. I don't want to forget to say thank you very much again. Number one is to my colleague, to Michael Schiebel, the man behind the camera, and he just promised me that he seriously will consider to show up in front of the camera as soon as we have achieved 100 followers here at YouTube. So please follow. I also want to say thank you again to Miriam Grossmann. Miriam Grossmann is our advisor, not only for videos, but also for the social media work and marketing overall. So she helps us to become visible to you, that you can reach us, that you can find us. Thank you very much, Ms. Grossmann. If you want to contact her, please let me know. I will get in touch, or you can reach her directly. You will find her in the social media, or you can find her via the RKW Baden-Württemberg. Thank you very much for your attention. Don't forget, like and follow, and all the contact data are in our info box. Thank you very much. See you soon again. Bye bye.